Okay, good afternoon, everyone. So my name is Alina Zare. I'm the director of the Artificial Intelligence and Informatics Research Institute at the University of Florida. I'm really happy you all joined us. We're going to have a discussion on human-in-the-loop digital twins for university operations, integrating Omniverse, CAE, and AI-driven development in student education. We'll explore a number of big questions. We'll talk about how do we best design a digital twin to be both human in the loop and impactful. We'll talk about how these platforms like CAE and Omniverse can reshape university operations, and we'll try and talk about how we can build students to lead these sorts of systems. So I'm here with Professor Karla Saldaña from the University of Florida and Professor Soichiro Ikuno from the University of Tokyo. So first, let me ask you both to introduce yourselves a little bit more. Karla?
Of course. Hello, everyone. My name is Karla Saldaña Ochoa. I'm an assistant professor at the School of Architecture. I joined UF in 2021 as an AI hire. So most of the work that I've been doing as a professor has been teaching and developing classes where I implemented AI for architectural studies, and then also developing research around digital twins. And I lead the lab that is called the SHARE Lab, which is a spatial human-centered AI research and experimentation. So all of the work that we do is on how to implement and think about projects that need AI and which of the projects don't need AI in anything that deals with the built environment.
Okay. My name is Soichiro Ikuno from Tokyo University of Technology in Japan, and I have a role of the director of the Digital Twin Center in our university. And actually, my major is high performance computing, and then also simulation of the electromagnetic wave propagation, and then also the engineering phenomena or physical phenomena. And just half years ago, our university installed the DGX-B200 like Hypergator 4. It's just a square size of the Hypergator 4, but we named Seran. It's named of the blue gale. It's meaning of the blue gale. But now we are constructing to fully operation. Maybe the next April, so next month, will be our operation will be started, fully started.
Wonderful. Yeah. So that's exciting. We're hope we'll hear how it goes.
Yeah.
Sure, Becca. Okay, so I'm going to start with you. How do you define digital twin?
Yes. It's a little bit difficult to define the digital twin because the traditional simulation, it looks like the really same to the traditional simulation, but the ordinary simulation is just calculate a once. And on the other hand, the digital twin is connect with the real world and the virtual world, and then data is going back and forth. And they optimize the real world phenomena. So essential difference is the data back and forth, I think. But CAE is the engine of the digital twin, and it helps to think the digital twin as a system that it integrates the CAE as an operational infrastructure. So this is ideal things, but the real-time data back and forth is the real digital twin. But this is currently an ideal, not a reality, because of the significant barriers remains. One of the things is the CAE solver computation time, such as fluid dynamics or electrodynamics analysis, become heavier and heavier. And the latency in the sensor data transfer between the sensors to the computer is second things of the problem or issues. So trade-off between the model update frequency and the computational cost is the third issue, I think. So the practical operation means a near real time or the event-driven periodic updates. Yet this is the fundamentally different from the static simulation.
Yeah. Okay. Thank you. So a lot of promise there, but still some challenges to work through. Karla, where are you seeing early stage digital twin concepts influencing university operations?
Particularly in university operations, we've seen the development of building digital twins, so trying to develop digital twins of building facilities. In the University of Florida, we had a project that is trying to work with the building life cycle, which means that we have digital twins that start from the feasibility part of the project, which means once you have the funding and once you have an idea of a building, you can start creating a digital twin of that building. Then to the design part, where you can use existing modeling techniques, like we have in architecture and engineering, we work with BIM models, which are building information models. If you think about them, they are like CAD drawings, but you're able to embed metadata and able to embed different static data about elements on the building. Then we move to the construction's building life cycle of the building, where you can create a historic, let's say, transcript or a historic version of the building as it's been built. So you have a digital replica of the building that is going to be built. And then when you go to the next session, which is the maintenance and maintenance of the operations of the building, you can use the existing data that you collected while you were designing, constructing, to be able to, for example, see if you have to renovate a building, there could be some information where were the things that, for example, the AC systems, where are the cables, where are the different infrastructure that was built before. And this is on the building itself, but then one of the important things that the building, that a digital twin for university campuses could work is, for example, when you're trying to identify which rooms are being under-occupied or over-occupied, where can you make the decisions of increasing the capacity of some classrooms, for example, or if you would like to understand if there is, for example, in the case of our buildings in the University of Florida, we want to know how to optimize the energy consumption. So if you have a digital twin that has information of how it has been built, where are the different systems that are required for the building to operate, then you can make assumptions and simulations to test whether you could improve the energy consumption before you ever make any decision on the building itself.
Yeah, that's true. So I think these are great insights. And I guess hearing from this, there's a lot of ideas for where we hope the digital twin will go and concepts for how do we deploy them in university operations. As you're building this out, where do you think needs the most human oversight for these systems, for either of you?
So I think my answer to the previous question went to too many layers, and I would like to unpack them so to understand where the human in the loop is relevant. Here, I find that when we are tasked to maintain or to design or to construct parts of the university campus, there is always a decision maker. So for example, in the case of planning, there is the urban planner or urban designer who needs to decide where to build the building. And in order to know where to build the building, you need to go to the map layers to know where are the environmental hazards, where are the different specific layers of data to know that that's the base site and the base place for that building. So digital twins can help not only to visualize how the building will look like when it's there, but also could help you see kind of the the layers of data that are not directly visible. Like, for example, you could be able to see environmental conditions, like if you load a model about flooding or about rain, you can see that even before you start modeling the design of the building. The human-in-the-loop approach is not only in making decisions after you see those scenarios that have been tested, but also to decide which type of data are relevant for the question that the digital twin is trying to address. Like, for example, we have a project in Jacksonville where we wanted to identify if there is any correlations between built infrastructure, like septic tanks, with weather conditions, like flooding, in the outcome of health outcomes, for example. So in that way, we wanted to partner with people who were experts on the building conditions, engineers. We were wanting to pair as well with people who were experts on modeling, so weather-related modeling, and then as well with health specialists. So the human in the loop is not only about deciding the data, not only about making decisions, but as well as coming with a question that is relevant for building a digital twin.
Soichiro, do you have?
Yes, but this is not the same situation. And frankly speaking, the Japanese university doesn't actively commit to the smart campus. Mm-hmm. So, because it's the root problem is the lack of the culture and the structure for the researcher to engage into the management of the campus operation. But our university now, we are trying to make some autonomous bus service between the nearest station to our campus. And maybe this is well known that the Waymo is already achieved the level 4 autonomous driving. But our universities try to make some level 2 autonomous buses. So that is the one of the human in the loop because the level 2. Mm-hmm. So some incident is occurred or some parking car is parking mm-hmm. at the road that we have to treat because of there's no training data to autonomous bus inside right. of the autonomous bus, so that we have to check or the operate mm-hmm.
to.
So that is, I think, that is a kind of the human interview for the autonomous bus and also the AI.
Yeah, wonderful. So there is some discussion of how do we bring humans in the loop for some of these systems, right? If we okay, so this is very interesting. Let's switch some to application of digital twins in the university campus. So Karla, I'm going to ask you a big question. If you're advising university leadership on this, where would you start? So let's say a university wants to start thinking about digital twins for university operations.
So I will, in order to answer this, I would like to describe what I think about what are digital twins or how I define them. So digital twins are virtual replicas of physical systems. And there is different levels of a digital twin. So there is a digital twin that looks like the physical system. So in the case of a university campus, you will think about having all of these different BAM models and the road network and the, for example, the sidewalks. That could be just how it exists. But that's one level of digital twins. The next level of a digital twin is to be able to load data that is happening at the same time, like we call these IoT networks. So you would like to have not only static data, like what we talked about BIM or GIS models, but you would like to have real-time data, which is coming from a network of sensors. Depending on what you're capturing, in the case of the projects that you're seeing on the screen, some of them are capturing weather conditions, some of them are capturing energy supply. So all of these are coming from this IoT data networks, but the idea is not only that you're receiving the data, the idea is that you have something called a bidirectional data connection, which means that the model, the physical campus is connected to the virtual replica. And so if I have to talk about what will be a recommendation for university officials will be to think about how do you connect this ability to create these 3D replicas or virtual replicas of campus with this data that is needed for a particular digital twin project. So the two examples that I have here are one about the correlation between physical assets like septic tanks and flooding to see if there is any health outcome related to that. So I will recommend if you have data that are collecting water quality or data that are collecting any specific outcome or any specific stream of data that is relevant to identify an outcome, I would like to connect that to the physical, to the digital twin. So that's a recommendation to find who has the ability to create a virtual replica and who has the ability or has the networks already deployed to talk to each other to make that joint.
Right. And so this is what Soichiro said about the real-time data being
Yes.
essential for the digital twin.
Mm-hmm.
Yeah, that makes a lot of sense.
So I think
go ahead.
the one of the real-time data back and forth is one of the challenging things. But one of the solution is to use the PINNS. It's a kind of the physics-informed neural networks. It's a kind of the AI. And then also the surrogate model. It's also the kind of the AI to get the result from as soon as possible to achieve that kind of the big issues. So I mean the real-time data.
Yeah, I think.
Go ahead.
Because I think the problem is not that we don't have the data. The problem is that we don't have the models to make decisions based on the data. And when I say decisions, not only decisions, but informed decisions regarding the data that you're getting. So these physics-informed models, these what we're calling physics AI, are models that are trying to replicate what physical phenomena are. Like, for example, in the case of weather, we'll be trying to create a model that is able to predict flooding, for example, or in the case of air fluid dynamic models that are predicting how air will flow. And then in the case, for example, of other that is not related to weather, but like traffic, for example, creating a model that simulates traffic, that is something that is like attached to a physical element in the world. And then, you talk about surrogate models, so they are only relevant when you have enough data to train those models. So the data is not the problem, it's the ability to get models and questions and research questions to help them define why you're building this digital twin. Because I think digital twins are not the answer, AI are not the answer. I think they are one of the tools that you can use to get to a solution.
Okay, so if this is so I have a follow-up question for you, Soichiro. If this is a tool to help us get the answer, what sort of operational decisions are at a university could be immeasurably better if we have a digital twin in place and when humans are in that optimization loop? Any ideas?
I'm sorry. So okay.
So I'm asking about if we're able to deploy a digital twin for any question around the university. Are there decisions that we can use those twins for when there's a human in the loop that makes that decision-making process better?
As Karla said, the digital twin is just not the real data. So I mean the true answer. And then also the physical is not optimal. So we have to check both of the data to connect which one is better to connect. And then also we have to help the optimal data in the physical. And then also we have to calculate and help the virtual data. So that is one thing to human in the loop of the digital twin.
Is making sure all those
Yes.
connections
Yes.
are appropriate. That makes a lot of sense. And so what do you see of all these pieces, what do you see as the biggest friction for deploying something like this? Is it data pipeline? Is it interoperability?
Okay, so honestly, the integration of the CAE or visualization, such as the Omniverse from the NVIDIA, there is it's more harmonious than I expected.
Oh,
so it's
really?
easy. So maybe 2 years ago or 1 year ago, it's very difficult to connect the data and the CAE data and the visualization application. But then nowadays, it is much easier to connect that between the CAE result and the visualization data. So so I think the real challenge is a result validation. So I'm a simulation side person. So the CAE application is going better and better, and then easy to get the result from the application. But we have to consider, or we have to check that result is correct or not, or it's suitable from the situation or the phenomena. So that is the responsibility for the human to check the phenomena. Yes.
This validation
Yes.
step. Yeah. Okay, so I guess I'm hearing that it's surprisingly easy to set these up, but then we have to figure out this assessment pipeline.
Yes.
How do we?
Yes.
Sure. Okay, that makes a lot of sense. So Karla, along these same lines, if we want to deploy this in the university system, we have the infrastructure set up, we figure out a way to validate it. It still requires bringing together a lot of units to actually use a digital twin at a university. So how do you see bridging computing? If we're talking about pins and surrogate models, this is bringing in research faculty because it's that whole area is still under research. How do we do this effectively? So bringing in AI institutes, faculty researchers, and then we also have to link them with university operational units. So how do you see that coming together? What might be a way to bring those units together?
Well, I think that what digital twins enable is to have a common space to see things together. So there is this narrative of saying an image is worth 1,000 words, a video is worth 10,000 images. If you think about a digital twin, it may be worth 1 million of those words or images. And why am I saying that is because a digital twin doesn't necessarily have to look hyper-realistic, doesn't necessarily have to have all of these game engines-like approach, but it becomes into the sense of digitalization of processes. And in order to answer your question, I have one of anecdote. I was reading this book about how England created their digitalization of their government, and the first recommendation that they had was, let's try to just have one website where every institution and government agency sits on. And let's try to have one format. So that is what I say is, my answer to your question is let's try to have kind of the basic of a digital twin where everybody could see its potentials for all of these different entities or colleges or departments, in the sense that if we define what is a digital twin as its ground truth, it's saying it needs to replicate a physical thing that doesn't necessarily need to be a building. It could be a process, it could be a system, it could be a human, or for example, I was even thinking that it could be the way that you handled files in your department. If we are able to replicate that digitally, what is the things that we need right now? What is the long-hanging fruit that we need and we have to arrive? If we're able to solve that question, then we can start adding more layers of complexity. So I think in order to have all of us looking or going towards creating a digital twin at the university level, we first have to define what is the most basic level of a digital twin, and then everybody has to agree on that level, and then start building up on specific case studies. Because if you try to have one digital twin for everybody, it doesn't really make sense. You probably just need to develop a framework or a protocol to help everybody bring their ideas, their projects into different digital twins with different use case.
Okay, so I'm gonna ask you a little bit more about that, because if we build out different, so first I'm hearing we need a baseline that we need all these units to agree on, and I'm gonna be the skeptic, as we can never get everyone to agree on everything, right? And so that's a hard challenge starting out. And then if we do that and we build out separate digital twins, I guess I'm wondering if you're then missing out on the opportunity for various units to learn from the other digital twins. So for example, if we have one digital twin on the transportation infrastructure of the campus, and we have another digital twin on the heating and cooling of our buildings, it seems like there'd be an opportunity for them to talk. There's a lot of traffic going to the auditorium. Maybe we should increase the cooling in that building, this sort of thing. And so does this method limit that? Or how do you see that coming together?
When I think about developing a baseline, I imagine a protocol for data aggregation, a protocol of how will you load machine learning models. So it's not about giving you a software and saying use that and then we will never see your project again. Is to say if we follow this pipeline, then your data will be able to be correlated or related with other type of data, because we're having the same data harmonization method. If we're saying we're going to build a machine learning model for electric performance prediction, but it needs to be in this set of, I don't know, software, not software, but it needs to be deployed in this way, then if you have a transit model, it also needs to be following the same protocol. So what I'm thinking about developing a digital twin is not having a software so we just use the software, is to say we have some rules of how data needs to be organized, pre-processed, and then how models need to be deployed. So then whenever we need this data to talk to that other data, if they have the same logic behind, then we can have them harmonized. And then I think the same thing with models. So if I'm saying no, you don't need to have a hyper-realistic digital twin for it to be a digital twin, I said about there are elements that we need. So data, which could be historic or static data, and then I consider these future data, which be all of the simulator-based data, and the real-time data. These three types of data, they need to be at the same, with the same structure. So that's what I think is the baseline of the digital. And then if you think about models, you have the traditional AI models, you have machine learning models, you have now the physics-informed models, and you have other type of models. They all need to have, or their output need to be within the same data structure as here. And then then later you have the visualization realm, right? This is a different thing. If you want visualization to be interfaced through goggles, through a web base, through a computer, through sound, then if these two other bundles of data and models are already clear, then the visualization is also streamlined. So that's what I'm thinking about developing a protocol and a baseline digital thing, is to develop that sense.
That structure that can make them more
exactly
compatible.
interoperable and compatible.
Yeah, that's right. So Sharon, I'm going to go back to you and loop back to the previous question about the friction, and you mentioned validation. So given what Karla is saying of we're going to have a way to go is having all these digital twins, and if there is, as you both say, these AI models of various types embedded in them, how do we what is the work being done, and how do you validate these systems?
I'm hearing the discussion, both of you, and then I think about it's the same situation like the multi-physics. So multi-physics, different digital things exist in the world, and then if there exists 100 times larger than the hypergator 4, or 500 larger than the hypergator 4, we can calculate all the things each other. Like the multi-physics. So yes, I just think about that. So
Yeah.
there is the large supercomputers that we can achieve that such kind of the different digital twin and then connect each other and then data transfer to each other. Yes.
Great. And do you think, what might be directions to validate these digital twins? I know you said that's a big potential bottleneck.
Yes, potential bottleneck, and then also it's depend on the student education as well, because I'm from actually the computer science faculty of the computer science. Most of the student doesn't have the deep knowledge about the engineering or the physical phenomena.
Right.
But so as I said before, the how do I say maturation of the CAE is going higher and higher. So maybe you saw the fluid dynamics simulation in the movie, the background. It's made by the computer science student, and then she doesn't know what the phenomena is, and then also she doesn't know the PDE and how to solve the problem. But she just try and then just challenge to use the CAE application, and then make that result, and then discussion with me. This is the optimal or the suitable result, and then combine to visualize like this one. So the validation is the most important things to create the digital twin, I think. But it's really necessity for the student education as well.
Yes.
So we have to discuss, and the student just try to use the CAE application to create the phenomena, and then see the result, and then feel which result is the suitable for the result for the digital twin. And then after that, the student started to run the real physics, and then also the mathematics and the numerical simulation, or like that.
Yeah. Okay. So this is a good point that you bring up, is that if we're going to start employing digital twins as core infrastructure, we need to train our students differently so they can use these systems and be prepared to lead them. And so what I'm hearing from you is this validation. The importance of validation helps drive that, but also, wow, we need really we need to start moving towards more interdisciplinary training as well. Do you want to talk more about interdisciplinary training a little bit?
Okay, so maybe 20 years ago or 30 years ago, when I was a candidate, the PhD candidate, we start from the theory of the physics and the mathematics, and then moves to programming technique, and then moves to numerical simulation techniques, and moves to visualization techniques. So it takes a long time to create the simulation, not a digital twin. But nowadays, as I said, the maturation of the CAE is going higher and higher. So the students, first reproduce the tuned phenomena in CAE, and the next one view the result, and then feel the result, like the fluid dynamics or like that. So after that, most of the students want to know more and more deeply and deeply, and then they start to learn about the physics and the mathematics, and then also the numerical simulation. what is a numerical simulation. So I think it's a little bit different from the ancient, kind of the ancient,
Yes, the ancient days.
the development, but now is yes, it's so different from the 20 years ago, or 30 years ago, yeah.
So, okay, so Karla, I'm going to switch to you on the same topic. You know, in training, where should digital twin training live? Is it engineering, data science, architecture? You're in the School of Architecture. So I'm hearing when computer science students work on this, they start to having to learn all these other disciplines. Where do you think that's the right home?
So I can probably answer this with the description of my career path. So I started in architecture, and on my graduate studies, I did a master thesis on laser scan, like point cloud models. And I was trying to represent the physical environment through different and more efficient methods. So then I use laser scanners to collect to scan the environment. But then I realized that effort was only to show how it looked. But in order to be able to make it be what it is, you need to run data and train models to be able to simulate, to classify, to predict different phenomena. So then that's how I transitioned to do a PhD on AI. So that's my path. I think as an architect, I was able to see the benefit of, and I mean, a lot of the work that I do is on the building and the city or anything that has that deals with environments, man-made environments. So for me, my path shown me that I can't be on the siloed work of architects if I'm going to go to the future of the profession. I need to train myself into understanding why it's needed to learn about data and data structure. And not only to know what is an AI, but also, like I always have this analogy with technology throughout the years that they could be seen as tools or instruments, tools like a hammer that is built for that specific thing to hammer things. It's optimal, it's fast, it's very precise, but then you also have instruments like the violin or a piano, right, that needs to have a human that is trained to play the piano or the violin to tune beautiful music. And then with instruments, you know that there is the expert to create the violin. You know there is the expert to play the violin. You know there is a composer, there is a director, there is a musician. So there are different roles when you are playing an instrument. And if I play the violin, it will sound terrible because I don't know how to play. So that's what I think about where the training in the future should be, is not only to know how to prompt AI, it should be about to learn what type of AI we should use for specific problems. Because right now, one of the things that I teach my students is, for example, there is a huge push to do agentic AI everywhere, everything. We want to solve something, it's like, let's create an agent for it. Let's create the environment, the data, and then let's deploy it. And I was like, but this could be simply solved by a classifier. And we have that. It's very cheap. It's very easy to do it. Why do you want to use that much resources for that question? So I think that's the need for having foundational classes where we teach that there are other types of AI. And when, for example, when there is some, on this video, there is a round diagram where I talk about how I envision digital twins to come. And I think we have the need for a cyber physical systems, but I add the idea of social cyber physical systems, because digital twins at cities, at buildings, they always have people on it. So we cannot avoid talking about what is the interaction of people with the digital twin. How do we bring those decisions, those social implications into a cyber physical system? But when you look at the part of the technology, I have one continuum that I call abstracting. So abstracting in the sense of representing the physical environment, but then also adding data models, then also adding physics-informed models. And then if you see in the social part, I think it's really important to know how we are going to interact with these models. So there will be ways that you have to interact in a very shallow, I will call it shallow in the sense that I will just ask a question and something will come up. But I think there should be a way that you can really go into the back end and be able to modify and be able to change. And that's what you were asking about, how do people in computer science or in medicine can talk to people in architecture if we have a common language of, as I said, data models and then eventually validation, which I also have some, maybe not ideas, right? Then we can work all together. I forgot what was the question initially.
The question was where, yeah, no, but I think this is leading to that. You know, I originally asked the question of like, what, you know, if we're, you know, training students to use, develop, deploy digital twins, where should that training live? And what I'm hearing from you is everyone needs some access to that.
Yeah, everyone. And then in architecture, I developed this AI certificate, and its foundation started with the university-wide AI certificate for undergraduates that you think of having fundamentals of AI and fundamentals of coding and computation, but for architects. Because the way that other disciplines talk about the fundamentals of computation is different than for architecture and for designers, for example. So having classes that are talking about those fundamentals of coding and computation for medicine, for engineers, for architects, for lawyers, for all of these different disciplines, it's something that we need. And then not only that, but the idea of ethics. How do you talk about ethics and AI in architecture? How do you talk about ethics and AI in engineering? And then there is the other course, right, that is the most applicable. In our case, we call it machine learning for architects. So that's how I see. If we're talking about digital twins is leveraging data model, AI models, and all of these different interfaces. So that's why I see, if I talk about AI, it is already implied that it's going to be used in digital twins. So if we train people on AI foundationals, on AI ethics, and on AI applications, they will be able to use digital twins because they will know how to get there.
Okay, that's very interesting. And so since you brought up ethics, I'm going to talk a bit more about ethics. But you know, what I've heard so far is, well, there's tools that are ramping up, maturing very quickly to help us develop these digital twins. And university operations is an excellent environment to kind of test them out and build them out. Not only do they help the university, but they help us advance the research that we need to deploy these. And it gives us a good framework for student training, right? And thinking about what do we need to train students in this area. So I'm going to take your cue. I'm going to shift to ethics a little bit. And so, you know, we talked about human in the loop, digital twins. And so human in the loop makes it sound reassuring, but it also sort of implies who's accountable, who's liable for the outcomes of this digital twin, right? So I'm going to ask, when a digital twin makes a recommendation and it affects real people or real infrastructure, who do you say is responsible for that? So let's say, you know, I don't like the way my air conditioning is handled in my office. Who do I call up? The digital twin designer or who?
So I talk about a shared responsibility. I think the moment you make a decision with any tool, you have to acknowledge what tool you use, what type of data was used to train the tool, and who built the tool. I think it's the same thing when I was telling about the violin, right? If you go to a concert and then you listen to this beautiful music, implicitly you know that the person playing needed to have these many training years and be able to practice daily and so on and so on, right? I think there is a moment where you have to take and acknowledge. Right now with all of this technology development, the shared responsibility. If I make the decision, I mean, if you're talking about a user saying, I need to change the temperature of my room, then you are the responsible if you change it and everybody complains, right? They will come to you because you changed it. But there are other things, like, for example, budget allocation. If someone uses a type of, like a tool like this to make such decisions, you need to be able to have a level of transparency of how this decision was made. right? If you were using a particular tool, if you were using more recommendation or traditional ways of decision making, that needs to be embedded into the decision itself. So if I'm making the decision, I'm a policymaker, and I'm saying that's the thing that is going to happen, I should take responsibility, full responsibility of how I got there. So, and with these different, like generative AI right now, it's so easy to be absent to a decision. So you say, it's there. It just produced that. But I think if you are, that's what it comes to ethics. How do you talk about the output of a model if you are the one putting it there? So
Yeah.
I think it's a shared responsibility. It needs to be always, you need to talk about data models and algorithms.
So Soichiro, I'm going to ask you the same question. I'm going
Yes.
to give you a scenario. So
This question is very simple. So I think it must be right because the AI or digital is set to, and it is the same structure as it must be right because an authority or the celebrity says so. It's the same situation, the structure. So I think the responsibility is for the human must have the responsibility for the final decision. So I think the AI and also the digital twin is one of the tool or one of the suggestion they gave us. So the final decision must be made by a human. So I think it's very simple for me. Yes.
Yeah. Okay. So and I think that makes a lot of sense to me. You know, my research work, we developed AI tools, and often we had human in the loop. And what we've noticed is sometimes people they start to trust the system too much, right?
Yeah.
And so we have to keep this in front of our minds that we are the ultimate decision makers, right? So, you know, I'll ask another question related to this. And this is talking about privacy and students. And so we've talked about things like building operations are more abstract, but there's also the university operation side of things where perhaps we have a digital twin. You talked about traffic that models student movement, right, or attendance patterns. Then we start to get concerned about privacy issues. So what is your thoughts on this? How should we approach trading off optimization with some of these privacy issues? Can I start with you? If you have
It's very difficult. It's a kind of the security and the privacy policy, and so it's basically the individual information cannot put into the AI. It's the normal things, and then also, but I think the digital twin need the data to create the virtual the world, and then also the AI also need to create the result by data from the data. So they need also the data. But it's I think so. I'm sorry, I don't have an answer, but it's very difficult.
It is a hard answer.
Yes,
Yeah.
It's related also the security and then also the information policy for the individual. But yes,
Right.
I don't have the exact answer right now, but yes,
Yeah.
we have to think about it.
It's a
Yes,
hard problem
yes,
that we
yeah.
have to think about, right? Absolutely. Karla, do you have thoughts on that?
I think, so in history, we've solved this problem by creating a data aggregation units, like for example, census tract or zip code areas, right? We aggregate data, so you cannot de-identify, you cannot specific say who is where, right? We have these large areas, and they have been, in some cases, helpful because you could project and you can show some specific data patterns at that scale. And I think in order to continue with that way of thinking, because I think it's correct, right? You don't want to be able to say that one person, it has that, it owns this house and it has this much money and it is in this any demographic information, right? You say about the whole census tract block. But I think those data aggregation units are becoming less useful when you're trying to make decisions. Like, for example, you're talking about the university campus and the specific population that is student and faculty. I think we can go in the same way. We can find ways to create these new units that are more data-driven. So instead of, if you're going to make a decision about how to define parking places, you don't want to know exactly what's the name of the student who parks or who lives where, right? You need to know when it's coming to the university, and you can de-identify that quite easily. But if you want to make decisions about which department needs more budget to be allocated because of these many students coming from, I think there you need to have a data aggregation method that is answering or that is reflecting the specific question that you had at the beginning. I don't know if I'm making it too complicated, but I'm
so there's no one size fits all.
Yeah,
we have to make
exactly.
sure it's appropriate to the problem. And,
Exactly.
And probably a lot of the privacy and what I'm hearing, some of these guards we have in place will transfer over, and some we need to think a little bit more deeply about. So I have one last question, brief answer, and then we'll open it up to any questions from the audience. So one quick response is, what will define a successful human-in-the-loop digital twin university 5 years from now, in your view?
Okay, I cannot talk about the 5 years from here because they maybe know that the AI and the digital twin, that technology is going to higher than the year by year or day by day. So last week I attended the GTC, which was held at the San Jose. The mainstream is OpenClaw. So OpenClaw is doing everything on computers. So we cannot imagine that last year that kind of the AI is constructed just only 1 year.
Yeah.
So I'm sorry, I cannot.
5 years is too hard.
I cannot talk about the 5 years. It's a far.
6 months.
Yeah, 6 months. 6 months or some. Yeah, but I think the OpenClaw is the next mainstream system, and then also we have to combine the OpenClaw to digital twin, and then we would try to combine that kind of yes.
Yeah, that's point well taken. This is really hard to predict. Karla, what do you define 5 years from now, if you dare?
So human in the loop, and I wanted to just go back to this diagram, and I think I tried to explain how I see of digital twins in these different continuums, from like the technological to the social. I see there is this abstracting continuum, which has a lot of the different models we showed today. We have, but if you notice here on the social continuum, I have this one that is called gaming, which has nothing to do with entertainment, but has to do with the ability of creating your own story. So if you think about games, it's not that you have a direct path to solve a problem, it's that you can build your path as you go in the future of the game, let's say. So here, that continuum is saying that right now, a lot of the digital twins that we have are about the connection of, I have a data, I input into the model, right, and then you see something happen. The next level is, I have multiple data, like a multi-model data set. You could input into the digital twin and see an output, but you cannot control the output. But maybe there is a way that you can have multimodal data with an output that you can keep having a feedback loop. And that's when I say it's important when you get to the human-in-the-loop approach, and you're talking about this way of creating your own narrative, is that maybe when you have a digital twin that is able to be customizable to me as a professor, a student as a student, a facility manager as a facility manager, then maybe the same model could be giving answers in the same ground truth for different needs. So that's, I don't know if that's the next 5 years. I find that will be an outcome that I would like to see digital twins doing.
Yeah, so that's a hope for the next 5 years.
It's a hope for the 5 years. I don't know if we'll get there, but.
Yeah, okay, thank you. So we have time for maybe one question, if there's any from the audience. Okay, well, then I think I want to thank both of our panelists. This was really interesting, and thank you all for coming.